in this lesson, I'm going to show you how to convert non-right triangle to right triangle so that you can use the Pythagorean theorem. How can I do that? So let's consider this problem. I have x and y coordinate, and I'm going to draw two vectors on this coordinate. I'm going to call a vector A, and let's say vector is 3 meter, and I'm going to give you one more vector, and let's call vector B. And vector V also 3 meter. Okay, so I want to solve this problem using Pythagorean theorem, but why then I have to convert it to right angle triangle first before I use the Pythagorean theorem? Because if I do use the Pythagorean theorem right now, then I will get the answer wrong. So I will get the answer wrong. So this is garbage, completely garbage, because this is not a right angle triangle. If it is not a right angle triangle, you cannot use Pythagorean theorem. Now, what is the requirement to be right angle triangle? Any triangle is made of 3 angles, and one of them has to be 90-degree angle, and there is no 90-degree angle here in this problem. How do you see that? Well, you probably don't see it. It's not probably 100% obvious, but I'm going to make it obvious. So I'm going to move this vector. I'm going to move this vector on the top. I'm going to put this black vector on the top of the blue vector by keeping the direction same. All right. So I just moved it so I don't have to keep it over here. So the original problem, let's put the original problem right here so that you keep track. This is the original problem. Original problem, I have vector A, which is 30 degree above the ground, above the x-axis, and vector B, which is 90 degree above the x-axis. Now I put the black vector on the top of the blue vector using the head and tail method. Now if I draw the resultant, then what do I see? I see this is 120. How do I know this is 120? Here's how I know. If I put this vector over here, this is 30. So I put a x-axis, imaginary x-axis over here. So I put 30 over here. If I extend this line, that must be 60. So this is a complementary angle. Okay. So if this is 120, this must be 30 and this must be 30. Okay. So this is an isosceles. So then this is not a right angle triangle. So if it is not a right angle triangle, you cannot use the Pythagorean theorem. Okay, now let's show you how to convert it to a right angle triangle. Okay, what do you see about vector A? Let's consider vector A for a second. Vector A has x component and the y component. Okay, what is the x component and what is the y component? What is the magnitude of x and what is the magnitude of y? Let's find that out. So this is 30, 60, and 90. So what is the opposite of 30x? What is opposite of 90? 2x. What is the opposite of 60? X root 3. So what is 2x? 2x is the hypotenuse. So what is 2x? 2x is a. And I gave you a. The value of a is 3. That was given. So 2x is 3. So then x is 3 over 2. So I'm going to replace x by 3 over 2. I would be able to convert it to right triangle now. So let's draw it again. All right. So first thing first, I'm going to draw the vector b. So this is vector b. Vector v is 3. Magnitude of vector v is 3. Now I'm going to draw the y component of vector a on the top of vector b. So this is the y component of vector a on the top of vector b, and that is 1.5. This is 1.5. That's good. Now I'm going to draw x component of vector a. X component of vector a. I'm going to draw x component of vector a, and that is this. And what is this? It's 3 root 3 over 2. Now I have a right triangle. So now I just made a right triangle. I can redraw the right triangle a little nicely, but you know, this is as good as anything. I can redraw it nicely, but I don't need to. This is fine. This is a right triangle. This is a right triangle. All right, so then we have the y component, which is 4.5, and we have x component, which is this one, 3 root 3 over 2. Okay. All right, so this is the right triangle because one of the angle is 90 degrees. So now this is the resultant. This is this one. All right, and this would be a plus b, just like this one. This is a plus b. Okay, so this is isosceles turned to a right triangle. By using some geometry, we made the isosceles to a right triangle. Now we can use the Pythagorean theorem, you know, and you love. So a plus b is equal to c square is equal to a square plus b square. So c square is a is 3 root 3 over 2 square plus b square 4.5 square. So c square is square root of 27. So c is 5.2. All right, so c is 5.2. Now we're gonna have to find the angle. What is this angle and what is this angle? All right, okay, so the tangent theta is y over x. So theta is tangent inverse y is 4.5 and x is about 2.6. So theta is, let's see what is the theta by using the calculator. So tangent, inverse tangent, 4.5 divided by 2.6, and that is 60 degree. 60 degree. So this one is 60 degree. So this one is 30 degree, must be. This is 60 degree. All right. So our answer is, so the problem was, this is vector 3, which is vector A, which is 3, and this is vector B, which is also 3, and A plus B, vector A plus vector B is 5.2. 5.2 at 60 degree above the x-axis. Okay, what does that mean? That means you have vector A, you have vector B, and then you have vector A, so this is 60 degree, and this one is 5.2. All right, so in this video you learn some new thing which nobody ever did before, and that is converting non-right angle triangle by using some algebra and geometry to right angle triangle so that you can use the Pythagorean theorem. What if you don't convert it to right angle triangle? Then you have to use the law of cosine. This video was sponsored by Brilliant.